Hey folks, happy Tuesday. Hope you're doing all right. Alrighty. There we go. Oh, that wasn't even set to where it should have been. That's okay. Uh-oh. My encoding's overloaded? Oh dear. Might be my laptop. Let's see. Crashed earlier on me. I think I was asking it to do too much. That's not a good sign. How's everybody doing tonight? Happy Tuesday. We've got a couple things to talk about tonight. First, I want to talk about the lab from last week, and then we'll get into Chapter 3, and we'll talk about our next lab. And if you have any questions about Project 1, please do let me know. There was one piece we had left for the rounding, and we're going to talk about today when we look at this primitive data types. We cover that in this chapter as well, so it should work out pretty well for you. Let's see, what is it even complaining about? I didn't even start net. Oh, it's this window manager. This thing is the worst. I don't know why I like it. I didn't restart my computer, and sometimes it gets weird when I put it to sleep. I wonder if that's why it's freaking out. But should be okay. We'll see. Maybe I'll restart at break time instead of having just music for break or something. Maybe that'll work. NetBeans. There we go. There we go. Come on, NetBeans. So let's talk about that lab first. Go to our assignments. So it was due by the starter class. That is less people than I would have thought would have turned it in. Yeah, so Loop, if they want to ask if they want to play again, we can take a look at that for sure. Yep, definitely. So do turn stuff in for partial credit for sure, like whatever you've got done, get it in. So make sure too, it's 2 steps. So committing to GitHub and pushing is step 1. It doesn't flag it for grading though unless you turn it into D2L. There's no link between the GitHub Classroom assignments and D2L. The link is you manually turning in the URL for me. So that's the step we got to do. Yeah, so definitely Tuesday is the busy day. I have 4 classes on Tuesday, so don't leave questions for Tuesday, please. Right? We've got all week to work on it. Ideally, you get it done the same night, but I get it. It's hard. 4 hours in one night is long. Like, and it's good to if you got to check out and go do something else, that's totally understandable. But you got to pick it back up before the next Tuesday, because I'm just not around at all to answer questions on Tuesdays, unfortunately. All right, so let's take a look at the lab. We'll do this one first. So the lab, the trick with that is we look at going from, hey, do you want to play one time to do you want to play always? Or keep on playing until you tell us you want to stop. So ask if they want to play. Great. So that's our step 1 here. So let's fire up a new project here. Java with Ant, Java application. Come on, next. There we go. Call this lab 2. And I gotta make sure I put this in the right folder. Remember, a GitHub repository is just a folder. So I'm gonna find the correct Tuesday night GitHub repository here in my GitHub folder. Here's GitHub. I gotta find CIS 1500. Winter for Tuesday here, not the Monday, Wednesday. You folks are different classes. Okay, loops are new. So the trick with looking at that was, if we ask them if they want to play one time, that's an if. If you want to keep on playing over and over and over, it just if turns into a while. You say, while you want playing, we'll keep doing this thing. We're going to start with an if, and then we'll add the while. All right, let me close out these other projects. Close, and close, and close. There we go. Gotta remember to do that before I stop. And again, I'm just getting rid of the comments because they bother me. I should just go change that template, and I always forget. All right, so a scanner for keyboard equals a new scanner given capital S system.in. Right, this is just a copy paste. We do this every time so that we can get input from the user. It's going to tell us it doesn't know what a scanner is. That's okay. You can either go type the import yourself, or NetBeans will say, hey, do you want to add an import? The other options are terrible. Don't use the other options, but just the add import is usually a pretty good option here. and it types the line for us. So we had a little bit of starter code, right? Our pseudo code out here. Let me open this one up. And again, the pseudo code, this idea is, here's the English steps. This is what I have to do. Right? So I'm just going to copy this in. Okay, so ask them, do they want to play rock, paper, scissors? Yes or no? So we'll print, do you want to play RPS? And again, you know, it's helpful to suggest options here, Y or N, for yes or no. Okay, give it a little format. And then we need to get their input. So their answer, right, is going to be as a string. A string is just a bunch of characters. Whatever they type in here is their answer, is going to be keyboard.next line. Right? Anything they type in here, we're going to grab as whatever they type and save it here as answer. Then, if they want to play, great. So we can say, hey, if answer, and remember, you can't use these double equal signs like we can with numbers. Double equals doesn't work for strings. We have to say answer.equals, and usually we want the equals ignoring case, because I don't know if the user is going to type capital or lowercase. So we'll say, hey, does it equal a y? If it equals a y, yeah, they want to play. Right? So now we're on to here. Right? Okay, so I know the computer's rock, so ask them, hey, do they want to be rock, paper, scissors? So you throw rock, paper, or scissors. And then we'll get their throw. I don't know, so string for throw maybe? Throw is not actually allowed. You notice it turns orange, and throw is a keyword here. We can't use throw, so how about, I don't know, their choice equals the keyboard.next line. Anything they type in here, we're going to save as their choice. Now we'll compare. Win, lose, or draw. Right? So if the computer is rock, right, then the player wins if they're paper. So if the choice equals ignoring case, again, because I don't know if they type uppercase or lowercase, if it's paper, then my set of curly braces, everything inside the curly braces will run if this is true. This is either true or false. You can say you win. If it's not paper, right, else if, is it something else? So what else should we check? So we checked paper. How about if it's scissors? If it's scissors, then a set of curly braces, we print you lose. If it's not paper, oops, and it's not scissors, you probably spell scissors the right way here. That'd be useful. Else if the choice equals, ignoring the case, if it's rock, then we tell them you tie. And then this is Java. Relax, man. Java. So if it's paper, you win. If it's scissors, you lose. If it's rock, you tie. If it's not rock, paper, or scissors, this was optional. You didn't need to include it, but we could have this else, this default case. If I don't recognize it here, I'll say that's not rock, paper, or scissors. I don't know, like ... Right? That's it. That's the game. So that's one time. So let's try it and see if it works. Let's give it a run. Make sure it works here. Excuse me. Oh my goodness, this properties here drives me nuts. This plugin. So I'm looking at alternate tools to NetBeans because NetBeans has finally got my last nerve here, and I've got a couple I'm testing out. So if I turn that off, and then it actually compiles when I hit run, because why wouldn't it do that? There, do we want to play rock, paper, scissors? If I say Y, or anything other than Y, it just stops. There's nothing happening. So if I say Y, then it's going to, okay, rock, paper, scissors. Let's try rock. Rock versus rock, and we tie. Okay, so it's looking good so far. So what we want to do then is we want to ask if they want to play again. Okay, so we'll say, do you want to play again? And again, you know, suggest a Y or an N, that sort of thing. And then we need to change answer. So we're going to reassign, we're going to assign a new value of answer here to whatever they type in. So, hey, do you want to try again? And go here. Now, what's up, Lemon? 4th time's the charm? You having some trouble? Hey, relax, man. This is an actual class, exclamation class for more information here. So we're going to try and stay on topic. I love talking about games too, but we'll focus on topic for now. So now we have the answer here. Great. But now the only thing that has to change here is we say while. So while the answer is yes, we'll keep on going. So if they answered yes, the while loop runs. Oh, changing the setting? Yeah, it's like every project. So sometimes the plugin is turned on and sometimes the plugin is turned off because NetBeans is weird like that. And I can go manually like turn it off and turn it back on and restart. And it's a big pain. So it's a quick setting, but I don't know why it doesn't default. Like, I don't know. It should be smarter and it's not. And I don't care enough to go fix it. So we're going to say while. So if this is true, the while loop runs. Remember, whiles are, say, if this is true, go from the curly brace down to the bottom. And then once you get to the bottom, come back up the top and say, are you still true? If you're still true, do it again. If you're still true, do it again. If you're still true, do it again. If you're not true, the loop will stop. So it goes from a single, if you want to play one time, to while you want to play, let's keep on going. Let's give that a run. Okay, so do we want to play? Yes. Okay, let's do rock. We tie. Let's play again. Let's do rock. We tie. Let's go again. Let's do paper. Paper wins. Let's play again. How about scissors this time? Scissors. We lose. Let's play again. So anything other than that is, that's not rock, paper, scissors. Dot, 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 dot. You want to play again? Yeah, so trying to do and like a loop after playing the first time, it could work, mock dizzy, but this lets us not have the same code twice. And again, don't worry too much about it. We're going to get more into loops in actually chapter 4. They introduce it here because otherwise the code doesn't make a whole lot of sense. Like, it's a very useful tool, so I want you to know that it exists. But we'll talk more about it in 2 more chapters. So I just want to put it out there, that it takes it really what's an if, and it will just repeat itself over and over and over and over again. And there's other loops we're going to look at as well, other ways of making our code do cool things. But that's it. That's it for the lab. Right? So this now becomes loop if you want to play if yes. Right? And then the computers always rock. Ask them. Ask the player for rock, paper, scissors here. And then we compare, win, lose, or draw. And we even added in that extra else case for fun. Right? We said, hey, let's add that else here if we don't recognize win, lose, or draw here. Oh, no, that's okay. This wasn't a requirement at all. This was just, I added it in for fun, right? I don't think it said that in the lab assignment, right? Just see if they win, lose, or draw. Yep. Oh, I'm sorry. That's what I meant when it said, loop the whole program. I didn't explicitly say while. I'm sorry. No worries. No worries. This was like the first real lab where I actually did some code. So, again, it's flexible. I'm not too concerned here. So as long as you get something in, I'm happy to work with you on it. Because ideally this is something we would have, sat in class and done like before you walked out the door. And then at that point, once you're already there on campus, you're less likely to be like, oh, sure, I just want to go because I'm tired and I'll do it later. You might be like, okay, let me try it for a little bit at least. So I'm happy to be a little bit flexible on these. And again, they don't make up much of the overall score either, right? Labs overall only make up like 10% of your overall grade. So it's not the largest thing. Yeah, iLibra. So if you can see it on github.com, I'll be able to see it on github.com. That's pretty much a good rule of thumb there. So if you follow those classroom GitHub links, it makes those repositories that you can see and that I can see, and the life is pretty good. So that's why we did our very first lab kind of for practice, making that work. So, hey, thanks so much for following along, Detonis. All right, so I'm going to come to GitHub, and I'm going to go check out our repository here. So 1500 for winter and Tuesday night. We should have a new project showing up. I see a Lab 2 project, so I'll say, okay, here's my commit summary. I'll say Lab 2 done. I'll commit and push, which will synchronize with the cloud, the github.com cloud. So all that code will be out there if you want to take a look at it. Go for it. You can peruse it at your leisure if you'd like. Oh, man, it is super dry now that the weather's so cold. Like I've got the humidifier and my heater, the whole house heater, but it still feels super dry. All right. Oh, and then ask if they want to play again. I forgot to move that here. Let's do that right here. Give that a little format. So I'm always hitting this format option under source. It's format. It's Alt-Shift-F. Will generally like put things where they should go. So if you got stuff weirdly tabbed out and other things like that, and it's all over. Oh, not that one. You can't go in the middle. Like all over the place. Formatting will put it back in a nice way. Elwalk, thank you so much for the posture reminder. I slouch all the time. I got this handy dandy backboard, which is actually really good for like stretching your back. And if I put it behind me here, it'll go in. Hey, no worries, no worries. It's, you know, we're still early in the class. We're figuring out how this all works, trying to get into the workflow. So, not too big of a deal. Happy to work with you on things. So, you know, I'm going over solutions, so like I can't really like take it late, that sort of thing. But you know, I'm generous with the partial points. So as long as you give me something that's close, I'm happy to give you some partial points on it. These are essentially participation points. I mean, like if you just turn in a print line and the print line says, I don't know what I'm doing, obviously there's no points there. But like if you make a good effort at it, that's fine. Hydration, thank you so much, X-Flynn. Now, my general rule of thumb is like when you're trying something, you know, again, the labs are a little bit different because this is meant, ideally, like I could walk around the room and help you. So I'm happy to hop on pretty quick. But when you're working on something, give it a good try, you know, maybe a good half hour. Less time with the labs, I think, because it's still super new. But like for project stuff or other things, at least a good half hour, maybe an hour of trying to figure it out yourself. After that, just stop. Just reach out and ask me, because if it's some silly thing like a semicolon's not there, or you didn't close a quote in, you're getting these weird error messages, and you know, if you have a capital letter somewhere, you get all these weird messages. Like this one's helpful. Okay, the semicolon expected. That's good. This one here says unclosed string literal. So you started a string and you didn't close it. Okay, sure, that one's kind of helpful here. This one says cannot find symbol, variable keyboard. That means it doesn't recognize it. So, oh, okay, well, there is nothing called a keyboard with a capital R because Java is case sensitive, so it's lowercase r. And you get all sorts of weird errors. If you're missing other curly braces in other places, like everything lights up red and it gets real upset. And then the suggestion is, okay, curly brace expected. All right, well, that one's kind of helpful there. You know, sometimes they're good, sometimes they're bad. So error messages get a little weird like that. Trey Ferreira, thanks so much for following along. So just let me know. Reach out. Happy to hop on. It's usually pretty quick if you can send me a screenshot, or if I can hop on and do a screen share, then it just works out pretty well. Yeah, definitely, Baka. Yeah, you can look over the other stuff we did for sure. So generally, the lab stuff is right from stuff we've practiced in class already, or I've shown you in class, and then you can go back and read other examples in the textbook. Again, I'm not going to generally follow the textbook much, because if I read the book to you, what's the point of you going and reading it? And then you've only had really one example. So I'm going to do examples that are close to what's in the textbook, sort of thing, like kind of following along topic for topic. So you can see it one time, you can go read it another time, and you can go practice it in the lab, and then you have a project about it, essentially. So the goal is you get lots of practice, because really the only way to get better at coding is by writing code. So every week we've got a coding assignment you should be working on writing code. You know, reading about something is only so good. You got to go get your hands dirty and try it and practice. And that's how you get good at something. Okay. Any other questions about the lab? We in good shape so far? And then just for fun, you'll notice Git here, it's tracking stuff at the line level. So I moved all my comments around, so it says, hey, these lines here are gone in red, and it says, hey, these lines here in green are new. They were added. So it says individual lines what was changed. It's really nice and handy for looking at that sort of thing. So I'm going to say move comments. As my message, I'll say commit and push. We'll go synchronize out with the cloud again. Yeah, so my goal is to talk for about 2 hours or so, maybe 2.5, depending on the night, depending on the topic, maybe a little less, maybe a little more, and then turn it over to you folks for lab time, because these are lab-based classes, right? It's not 4 hours of me talking at you, and then you go practice. It's, you know, half to 2/3 of the class, me showing you things, and then you practicing it while I can go walk around and help you. So in lieu of us being in the physical room together, we've got Discord, we've got Zoom, we can hop on and do screen sharing things. And it'll get us close. Let's be honest. It's not the same, but given the recent weather, hopefully that's one benefit, right? You don't have to drive out in the snow like yesterday to try and make it out to class. So there are some pluses with some of the minuses, and hopefully it all kind of shakes out and you feel pretty good about it in the end. So if something's driving you nuts or frustrating or crazy, please let me know. I'm happy to work with you and see what we can do to get things straightened out. So ideally it's straightforward and pretty works out pretty well. Oh, and we do have now our SI sessions. Mr. Tim had let me know, unfortunately had some technical issues today. Zoom is the worst. They have some really terrible password policies that are not to standard. There's this organization called NIST, which is really cool. So NIST is the National Institute of Standards and Technology, and they have best practice guidelines around things like cybersecurity. And one of the things is passwords here. So we just search password. Excuse me. You can see they've got really cool password management guides and this sort of thing that tell you, hey, what you should do with your passwords and good practices and things. And Zoom says, no, I don't care. Oops, we got to go find the new one here. Where is it? Oh my goodness, I searched the wrong location. How about password? Oh, come on. Maybe we'll find it here. Somewhere in here. Okay, I don't remember where it is. I just have to go find it every time. It's telling you all these effects of passwords and all this nonsense. So what does we want? Password, best practice. Come on. They have so many documents. It is a little overwhelming here, but it's kind of crazy. All right, none of these are what I'm looking for here. NIST password guidelines. They have a lot of documents here. We're pretty good at that sort of thing. All right, here's someone else's blog that's going to summarize it for us because I don't want to have to read it myself. There we go. So to summarize these different things here, holy cow. All right. Must be at least 8 characters in length. Sure. Minimum of 10 attempts before locking. Okay, cool. Don't use hints. Hints are bad, right? Because they help you guess passwords. Two-factor authentication is good. Password managers are good. Hashing is good. What's the... oh, my goodness. It's not length. It's rotation. No, so there's some guidelines, I'm not finding it right now, about how often you should make someone change their password and how it's actually dumb to make them change it every 30 days or every 90 days or whatever. And Zoom says, no, we don't care. We're going to make you change it all the time, even though it has no proven use here. Oh my goodness, why can't I find it? Rotation. Got to be in here, right? Here. Recommends against password rotation policies. Boom. SANS.org. Amazing. I love it. SafePass.me, complying with their guidelines. There. This is what I want to send to the folks at Zoom and tell them they're dumb. But, you know, I'm still new here, and technically a probationary faculty member until I've been here for 3 years. This is winter of year 2. So I've reached a little bit more than halfway, which is nice. But if I upset the wrong people, not that Zoom's going to care, but, you know, whatever. All right. Anyway, that rabbit hole. So Mr. Tim had some technical issues thanks to Zoom being stupid. And today's session, unfortunately, didn't happen. But moving forward, Wednesdays and Tuesdays are going to be our supplemental instruction group tutor sessions. These are fantastic. These will get you extra points. Mr. Tim takes attendance every time on Zoom. So you actually can tell him who you are instead of using your handles here, which is cool. I think the handles is actually fun. And I did get some feedback in one of those like end of semester surveys that hopefully you get for every class, and they are important and that sort of thing, but they said they were more comfortable asking questions anonymously, and that, you know, having their handles allowed them to do that, and I thought that was kind of cool. So excuse me. So supplemental instruction sessions, extra time to talk about things, group tutoring, focus on the class. So he takes attendance, and you'll get an extra point on that week's quiz. Essentially, I don't actually add them one quiz at a time. I wait till the end of the semester and I add them all together and give you a bunch of bonus points in the quiz category. So one for every week that you attend. And so those will start up this week, Wednesday, and then following Tuesday. So you can get a little practice in before class to reinforce some of those topics, or the next day after. And excuse me, hopefully one of those 2 times works for you. If it doesn't, and you go to individual tutoring appointments, I'll also give you those bonus points as well, don't forget. So you can have them either way there. All right, should we talk about Chapter 3? We start up a new project. No, not undo, not undo. No, I want to undo the undo. There we go. I think I did it. All right. This is Chapter 3. So Chapter 3 is all about taking a deeper dive on working with these primitive types, which is fun. So primitive types are essentially all of our numeric values, right? So we've looked at ints before. These are whole numbers. You know, some whole number is 42. And we looked at doubles, you know, some number with a decimal. A decimal was like 7.7, sure. And then I mentioned a couple other types, right? There's the char, which is a single character, equals E. And for chars, you use apostrophes, right? And then there's also this cool Boolean. Boolean is a value that is true or false. And you can either say you are true, lowercase t true, or lowercase f false, lowercase false, true or false, which is fun. So a couple types there. There are a couple additional types depending on what you want to do if you want to get crazy. So there are smaller than integers. There are shorts. So this is small ints. These only go up to 32,000 or so. So it sure doesn't really matter too much. We can give it some big number here, but you know, let's do like 30,000. Why not? And then when you're defining numbers, Java is really cool in that you can put an underscore in. It's not very cool in that you can put the underscore anywhere you want, and it could care less. So it ignores underscores in numbers. So don't be silly with them, but if you do underscores in place of commas, you're fine. Why it can't take a comma, I'll never know, but the underscore character is used in numbers for placeholders. So that underscore for, or no, it's not it's digit groupings, right? Digit groupings is optional, but recommended. Because it's much easier to see that this is 30,000 than to see this is 30,000. Because honestly, I'm going to have to look at it and count the zeros here because that's hard on my eyes. We have commas for a reason in numbers. If you want to get crazy, you can have a single byte. So byte is 8 individual bits. You can get numbers -128 to +127. This is a single 8-bit number. Here, like, I don't know, 100. Sure. You can store those as bytes. We can have smalls, we can have ints, and then if you need bigger than integers, we have long. So longs are really big integers. Their max is somewhere around, oh my goodness, what is that? Millions, billions, trillions, quadrillions, centillions. So 9 centillion or so. I'll put in the max number here. And I'm just cheating. I'm copying right off of the PowerPoint here. I don't like reading stuff to you, so I try not to put PowerPoint up on the screen, because then if I'm reading it, you've already read it because you're faster than I am, that sort of thing. But you know, some of these are important here. And then to make a number to be long, you have to put an L after it. It needs an L. That's a lowercase l. Does that make sense? So it's not a 1 there, that's a lowercase l. Here. It looks kind of like a 1. It's a little bit funky there. And you can't have the underscore there because there's no other characters. So that one gets a little bit weird, but that's okay. So these are all our whole numbers. Ints, shorts, bytes for smaller ones, longs for bigger ones, depending what you need to do. And then doubles, great. And we talked about floats that I hate here. So floats, these are smaller numbers with decimals here. Now, the reason I hate floats is 7.7 is not a float. 7.7 is a double. To tell Java it's a float, you have to put an F. No, you include the F for float. That's really literally the entire reason I hate floats, just because you have to add another letter. And, you know, having to type one more character obviously annoys me enough to make me not want to use them. So, and again, for our purposes, we don't care. We're spoiled. It takes up 4 bytes of memory instead of 8 bytes of memory for a double. Right? Remember we talked about how much memory our computer has? So a byte is 8 bits, right? A kilobyte is 1,000 bytes. A megabyte is 1,000,000 bytes. And a gigabyte is 1,000,000,000 bytes. So we have literally billions of bytes of memory that I don't care if you're using 4 or 8 for your values, because we don't have millions and millions and millions of these. If you're doing something in Java where you have millions and millions and millions of numbers in memory, then yes, by all means, please use the appropriate one. But for our purposes, we're just learning how to program. We're not doing anything at that scale. We could care less. Does it make us a little bit lazy? Yeah, sure. I'll admit that, and that's okay. I'm not going to be too concerned about that. So we have these 8 primitive types. We have byte, we have short, we have int, we have long, we have float, we have double, we have char, and we have Boolean. Actually, I learned there's sign language for 1 through 10 on your one hand, which I didn't realize before. So it's 5, and then I think it was 6, and 7, and 8, and 9, or something like that. I forget. But my youngest son loves Sesame Street, so it's on almost constantly. Don't judge me. So we learn a lot from Sesame Street. All right, so these are primitive types. Notice they're all lowercase, and they all show up in this reserved word color. So 6.6 requires an F. So anything that's a float needs an F to tell Java it's a float. Okay. Yep, so by default, if you type a number in with a decimal place, Java thinks it's a double, because that's our more common data type. Float is less common than doubles. Excuse me. Right, so those are our types. You can use scientific notation if you like. It drives me crazy because I feel like it always is hard to look at, but you can use scientific notation if you want. And then it's worth noting Java is bad at math. It's really bad at math. It's the weirdest thing here. So if I have, let's do like a bunch of different numbers here. Let's do, let's just have a double for the sum. Let's say this is going to be my smaller number with a decimal, plus my sum number with a decimal, plus, and let's add in some whole number. Why not? We'll just add all these things in together. Sum whole number. And again, if you're not getting these type aheads, like what that means is I'm typing a couple characters here. I'm saying, hey, plus, let's do the really big integer, and it like suggests it for me here. You need to go to Tools and Options. You go to the Editor tab, and you go to the Code Completion tab, and you pick the Java language, and you pick boxes 2 and 3, and you check those boxes. That will make sure that that IntelliSense or type ahead or auto-suggestion stuff is working for you. So you can have good variable names, and as you start typing a couple letters, it suggests it for you. And again, I'm a big fan of tab. So as I'm typing with my 2 hands, I don't take them off the keyboard if I can help it until I need to go get the mouse. So I'm not going to grab the mouse and come and double-click. I'm going to just move over to the arrow keys, and you go up, down, and up, down, up, down, up, down to pick the one you want. And then tab will finish typing it in for you. And then let's print out the sum. So let's see, what do we get here? It's really bad at math usually. Oh my goodness. Properties, compiling, uncheck compile on save, NB Java C, you are the worst. Try that again. Chapter 3, run it. Here we go. So somehow we had 7.7 plus 7.7 plus a whole number, plus 42, plus my really big integer, which was 9 centillion, plus my small int here. And we get out of that, where was our output here? Ends with 0.07? I feel like that's not right. Let's take out the really big integer. I'm sorry, let's take out the really big integer. So we do 7. So, and as I click on a variable, notice NetBeans here is highlighting where else that variable is used. It gives you a nice, really visual cue here of this. So 7.7 plus 7.7, we're at 15.4, right? Plus 42, that should be 57.4, plus 30,000. So 30,057.4, right? Let's see what we get. That is not 0.4, my friends. 0.3999999 is pretty close to 0.4, but it's not 0.4. So there's a funny thing, and really we don't care too much about it, but further on in computer science you can learn how floating point math is actually done on CPUs, on the physical chips themselves. It's insane. Right? I'll leave that sort of stuff for electrical engineers who are geniuses. I just want my code to make the computer go beep boop bop. But Java's bad at precise math with floating point numbers. So if you were to do something like write some banking software, you're not actually going to use doubles and floats. That's no good at all. It's real bad to do that sort of thing. Because as you can see, oh, where's my output? You get weird things here. Okay, so weird. So we'll just leave it a little note here. Bad at math relating to decimal places. And I mean, it's not actually off by much, right? It's literally, because we have how many? 1, 2, 3, 4 more decimal places. So this is hundredths, this is thousandths, this is 10 thousandths, this is 100,000, this is millionth. So it's 1 millionth off. Hey, thanks so much for following along. So we're only off by a millionth here. I mean, that's not bad, but it's not accurate. Right? It should be better, and it's not. So we just need to recognize that is a downside here, right? Okay. Let's see. So our different variables, we're good there. A funny thing about characters here, these are Unicode values. And you can actually go look up the Unicode table. So Unicode table, you can go look this guy up here. And each character is actually represented by a numeric value. Lemon, it's just bad. It's not right. I don't know if it's up or down. I'm not really sure. You can use math functions, and we'll look at those today actually, to make sure that it does round properly. But again, it's a little bit funky is all. So this capital A here is decimal 65. So a capital A is represented by 65, the numeric value 65. So if I wanted to, I can say char, this is a capital A, capital A is 65 numeric value. And Java is more than happy to let me assign that as a character, because a single character here is actually a number. So a capital E, right, I believe is plus 4, right? This should be 69, I think. Capital E, come on, 69. So that is actually 69 here, number 69. So 65 is A, 26 more letters, right, put you at a certain letter. And then it doesn't actually go back to some lowercase letters right away. You get a couple special characters, and then you get the lowercase a at 97. Don't bother memorizing any of that. It's not worth it. But just know they're actually stored as numeric values, which is super cool behind the scenes. Okay? So that's our character. So you can actually do character arithmetic and say, hey, let's add a digit to each character here for fun. So if I wanted to, I could say, hey, char, my first letter is E, and then my char second letter is R, and then a char third letter is I, and then a char fourth letter is C. And if I wanted to make it harder to see, like encrypting is the wrong word here, but encoding, doing like a cipher, I could hide what this is by just adding one to each of those. So I can take first letter and I can say plus equals 1. Remember, this is that combined assignment operator. That's also so common to just add 1 that they have another operator called the increment operator. So plus plus, same as above. It just adds 1 to the value. So that one's super common. You could do the old-fashioned way. Say third letter is the value of third letter plus 1. The classic slow way. And then fourth letter is misspelled here. Oh, goodness. Why does it not like it? It's warning me about possible lossy conversion from int to char. So third letter plus 1 is an integer, and chars are smaller. Chars are only 2 bytes. Remember, integers are 4 bytes. Well, that's unfortunate here. So this way is not, that's supposed to be classic slow way. It's not going to let us do that. So if we want to, we could really say, hey, treat this as a type of char. Oh, I'm sorry, char in the wrong direction. Parentheses around char. And say, parentheses on both sides. That's right. Say, hey, Java, do me a favor. Add this together. I know it's an integer, but then pretend it's a character for me. Don't worry too much about that. And then fourth letter, let's see, how else could we change that? So the other way you can do is plus plus, and then the value. So this is the increment operator, increment increment operator. And this is actually a pre-increment operator. So there is a slight difference here. So with the post-increment operator, you will use the value and then you will add to it. With the pre-increment value operator, you will add to it and then use the value. In our case, we're not using the value for anything, so it doesn't really matter too much. But then we can print out. We can say, I want my first letter, and then we'll print the second letter. Then we can print the third letter, and then we can print the fourth letter. Now, notice I misspelled fourth letter, and if that doesn't bother you, that's fine. I don't care if you have typos or not, but if it does bother you, don't go retype it here, because if I change it here, now these other ones light up red and they say they don't know what that is. So what you want to do, you want to use the tool. So right-click, go to Refactor, Rename here, and then you can fix your typo, fourth letter. And when you refactor, it's going to change it everywhere you have it used already. So it changes it in all those locations. Again, you always want to use those shortcuts if you got a shortcut available. We love shortcuts. And then I think we talked briefly in the book about print versus print line. So print will just print the message and then it won't go down to the next line. So print line gives you that new line character. So if I just print, and then print line, I'll get them all in the same line here. So I should get Eric, but one added. So it's F, R, R becomes S, I becomes a J, C becomes a D. And now you get Fizzgid. And now this is a simple cipher of my name here. Because you can do arithmetic on characters because characters are actually numbers. Right, that's the whole point here. So arithmetic works on Char because they are really numbers. Okay? Does that part make sense so far with this Char type? You can do some fun stuff with it is all. All right, other things you might see people do, and I don't recommend this, but you can. There's nothing wrong with it. I don't like it. Here, if we have some values here, like int first equals, we'll say 10. You can, if you have another integer value, you can say second equals 20 on the same line. I don't recommend this syntax. I'm just not a fan of it here. So, sure, it's a little bit more typing to go down and say you have another int, but it's okay. So you can have more than one on one line. Not a fan. Just for me, because I think it's obnoxious is all. There's a couple of cool things you can do with variables that you might consider a constant, like mathematical constants here. So if we have a double as, we'll say pi, for mathematical constants, you use all uppercase letters. Let me say 3.14159, something, so I forget how many it needed to be here. Oh, I missed my word here. Sorry. So we say it's a final double pi. And if you put in that final keyword, what it means is once you set the value, you can't go change it. So we've told Java, hey, by the way, this is the final value for this. Don't let me go change it. So I can't say pi equals 3.1, or what is it, 22 divided by 7. It won't let me go change it here. And I get a message saying, cannot assign a value to a final variable. So this is a set once and only once. So if you know you have some sort of constant value that you're not going to change, this is actually really handy because it keeps you from changing it by mistake. We're saying in the code, don't let me change this again by accident. Right? It's all about preventing ourselves from shooting ourselves in the foot, right? Which is really nice. So you can do all sorts of things with that, and then you can't change a final value. So I'm actually going to comment that out here because you can't change it, and otherwise my code won't run. Okay, so the problem is because we're using all uppercase letters, we can't do camel casing. So if you have some sort of variable, like what is a final int speed of light, right? Or if we just tried of light, that's really hard to read. So what you do is you use underscores then, speed of, oh, I thought it said speed of flight, and I was confused here. And then anytime you're using something in units, I'm going to say in meters per second, right? Tell me what the unit is. This is meters per second here. And I don't actually remember. Hey, Cortana. Oh, is it not going to work now? I was trying earlier. Okay, whatever. Let's just go Google it. Speed of light in meters per second. Oh, it had it. It had it there. Didn't even have to open Edge. That looks right. Why not? I trust it. Approximately. We'll use the exact one here. Again, you can't have commas, so I'm going to use my underscores here. So the speed of light in meters per second now is a nice, meaningful name, and I can't go change it. I can use this everywhere else if I want in my code. Okay. So we've looked at a couple of different, some arithmetic stuff before. Now, if you think back to third grade long division, right? In third grade long division, you learned how to do remainders, right? So like 10 divided by 3 was 3 remainder 1, right? So we can do that same sort of thing. So we can say 10 divided by 3 equals, and I'm going to print. Now, if I do the arithmetic, 10 divided by 3, what am I going to get? Any guesses here? Did we talk about this last week? I forget if we talked about this. I think we did. This is integer division. Right? With integer division, you lose the decimal. Lose any decimal. So 10 divided by 3 becomes 3, not 3.33333. That decimal is just gone. You get an integer result. Okay? So when I run this, nope, not format. I want to just run. I get 3. Well, that's not the whole answer here. So I can say a remainder, and then 10, oh, sorry, plus in here, 10 modulus 3. So modulus is the percent sign, is the remainder, or modulus operator. Remainder, that's not spelled right, remainder 3. Right, and now I can give that a run. And now I get, okay, we did talk about this. The integer division, right, but not modulus. We get 10 divided by 3 is 3 remainder 1. And again, if you wanted to, you could be fancy. Put these as like prints, and then a print line here, right? You know, kind of space it out yourself so that it comes out in a good format here. Go for it. Any way you want to do it, it's fine. So 10 divided by 3 equals 3 remainder 1. Cool. We can do long division now. Actually, we cheated. We made Java do the long division. Right, so it's integer division. So modulus is a really popular operator. Right? It will calculate the integer remainder of the division. Lots of cool things you can do with it. Oh, we should put this up here. Now we've gotten the wrong spot here. No, tab in, please. There we go. Okay, so this uses all uppercase and underscores to separate words in final variables. Here we go. It's kind of hard to tell with pi because it was just 2 letters here. But yeah, it's all uppercase separated here. We looked at incrementing, we looked at decrementing. That shorthand notation, that plus equals, right? You can do that with any operator. Plus equals, minus equals, times equals, divide equals. You can even do modulus equals, if you care to. No problem there. Order of operations, we talked about order of operations, right? Please excuse my dear Aunt Sally. It is very important, right, to make sure you follow your order of operations. Otherwise, you're going to get into all sorts of trouble. Let's see, we got some other examples. Yep, so smaller values will always fit into bigger values. So if I were to say, hey, a int, I want to assign it the value of a short, perfectly fine, because a short is smaller than an int. But I can't say a short equals an int, because an int is larger. I'm going to get those errors here. So when I look at my types here, if I were to say, say short ints don't fit equals the sum whole number, integer value, it's going to yell at me. This is incompatible types. Possible lossy conversion from int to short. It's invalid. Larger values can't fit in smaller values. Or types, larger types. Can't fit in smaller types. Now, if I just type in the value, it knows that it fits, because it can check it here at compile time. But this one's invalid. Okay, so you can always save an int as a double, but you can't save doubles as ints. I mean, those ones have decimal places, but if you're using these other types, just another reason not to use the other types. They're just confusing. You don't want to mess with any of that. So that's good. We looked at integer.parseInt and double.parseDouble. We did those ones. All right, some functions in the math library. These ones are really handy here. So if you wanted, then, if we wanted to say, hey, 10 divided by 3 is equal to, now if either one of your values is a double, like 10.0 divided by 3, right, then we're going to get the actual decimal result because one of the values is a double. Right, 3.3, but that's a lot of decimal places, right? And it even rounded weird. Should have been 4, right? I mean, it's like the zillionth place, so nobody really cares, but it's not accurate. So either side of an operation is a double, the answer is a double. So integer division is if they're both integers, you get an integer result. But what we could do if we wanted to round, so 10 divided by 3 rounded is equal to, and again we're going to do, now we're going to use this cool library. We're going to say math dot. So math dot gives me access to all things math that Java knows how to do. Java knows how to do lots of math. Absolute values of numbers, cosines of numbers, arc cosines of numbers, tangents of numbers. Ceil is super handy, and this is one you might want for your project. Ceil will, now the definition here is awful. It returns the smallest, closest to negative infinity double value that is greater than or equal to the argument and is equal to the mathematical integer. Equal to a mathematical integer. What? It rounds up. So 3.01 rounds up to 4. If there is any decimal, it will round up to the next integer. Right? That's what that does. So that rounds up. But math.round will just round the value. Right? We just take the number and round it. Now, we probably don't actually want to round, though, right? Because if we say 10.0 divided by 3, and we round that, we're going to get 3. Right? Because rounded will round to the nearest whole number is 3. That's not useful. We don't actually want that. Right? So depending on what you want to do, again, right, you can use rounding if that makes sense for you. There's square roots, there's min and max, so you can give it two different numbers and figure out min and max. And then you can also get random numbers. Random's really fun. So if you want a random value here, random number, let's do 1 to 100, is going to be math.random. And now random is funky. What it does here, random, let's see if we get that text again. I want that text. Random. There we go. It returns a double value with a positive sign greater than or equal to 0 and less than 1. Now, it does say it's pseudo-randomly. So it's not actually random. You don't want to use math.random here for anything that needs to be cryptographically secure. It's not really random because we know the code for how it generates random numbers. We can understand how it works. It turns out there was this really cool thing that went around. It said, hacking slot machines, bad random generators. There was a thing, yep, here we go. This was a really interesting article here. Here it was in Wired, that's right. So I don't know what the Schneier is. So Russian engineers cheated the slot machines. And yes, they do have a fix. This was wrong. They at this point in time, they didn't have a fix. But yeah, they know how to fix it now. So, right, you know, obviously they make casinos money. They're supposed to make money. But the code has trouble. So someone's cheating here. So somebody he didn't tinker with the machines. They were older models here. He held his iPhone really close to the screen. And he'd make a lot of money doing it, right? So what happened is, where'd it go here? You can guess the pattern here with the sequence. So it's not actually random, it's pseudo-random. So in a slot machine, right, you get all these different spinning numbers showing up, and the way that they coded it was just awful. They used the same random number generator to give you the random images on the screen as the actual random result. And no, I don't blame them, because who would have thought you would actually go and look at this? But if you were to take a video of those random images as they're flipping around, you could essentially figure out what the random pattern was. Right? It's pseudo-random. It's not actually random. So let me post this in Discord here because this was super cool. I think this is really fun. Do I even have Discord? I don't even have Discord open. All right, I'm going to come back. I'll just leave the tab open and I'll come back to it later. But pseudo-random, not good for cryptographically secure things. It's a number between 0 and 1, not including 1. So if you want a number 1 to 100, you're going to multiply by 100. Because it's 0 to not including 1, I will never get the value of 100 here, but I could get 0. So what I want to do then is add 1. Right, so random, math.random gives between 0 and 1, not including 1. Right, so we multiply by the largest value we want and add 1. Right, so that will give 1 to that value. If you want to be like, hey, I want a number between 10 and 20, right? Well, what we need then is we need 11 different values, right? 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 is 11 different values. So we want to multiply by 11, right? And then we want to add 10. Don't worry too much about it. It's not the biggest deal here, but that's how we generate random numbers. And it's not all that important. But I can get random numbers here, and every time I run this, it's going to look like it's random, and it's randomly generating new values here. So let's give it a couple runs. So we get 93. So if you want it as an integer, right, we should probably do rounding here. Let's do all of that then with, how about math.round? There we go. One more time now. That ought to work. Okay, random number was 1. Oh, look at that. Let's try it again. Run it again. Now we got 25. Let's run it again. Now we get 2. Okay. Now we get 3. Sure. 73. It's different. 54. Different. Again, it looks like it's random, but it's only pseudo-random, so be careful with that. So this is not actually random. Not actually random. Random. Be careful. Just, probably a long time until you're writing anything that significantly important that it could affect it, but just keep that in your back pocket that it doesn't actually work to be perfectly random. All right, we've been going for about an hour here, so why don't we take a break? We'll come back in about 10 minutes. We're through a good chunk of the chapter. We got some more weird topics to cover at the end here. I'm not too concerned about most of them. It's around formatting values. You can do some really pretty formatting stuff, which is fine. That's okay. Yeah, rounding. There's some other, like a big decimal if you want actually accurate, really large numbers with decimal places that are built into the Java library, not the double values. Those ones are really fun. We can do all of those. Yeah, so that would be a better program to do. Yeah, that's about it for the chapter then. So you folks are doing great. Hopefully it wasn't too bad. I know some of this was refreshed from last week, but last week was like our second week ever coding, and it was just a ton of information, so it's really good to kind of rehash it here. Programming is one of those things, a lot like math class, is once you learn something, you're never allowed to forget it ever again. And not that you don't have to have it memorized, but you have to know that it exists, and all these things build on each other. So once we learn something, it's another tool in our toolkit to be able to solve problems. And we learn more tools and more techniques to solve bigger and bigger and bigger problems. And that's kind of what we're going to do. So we're going to go through and learn lots of tools and techniques and different ways to approach problems and ways we can make the computer do cool things. And that's kind of the goal, okay? So why don't we take 10, and then we'll come back in a little while, okay? Or in 10 minutes, yeah, if we're taking 10. Then we put some music back on. Here, I'll restart that track. And then we put on our pausing screen. So that brings us back to, say, what is that, 7:15 p.m.? And we'll go from there, okay? Thanks, folks. Hey everybody, welcome on back. Alright, I forgot to get another can. Shoot, I'm almost out of liquids here. That is unfortunate, but that's okay. Alright, so we've gotten through actually a lot of the chapter. That's really good. Formatting stuff, if you want to make your outputs look nice and pretty here, right, which is really handy. It is pretty nice here. And thanks so much, King. Good to see you around. So let's say, hey, enter the price of an item here, and then we'll get their value as a double. We'll say double, here's the price, is going to be double.parseDouble. Right, we're going to convert whatever we get back from the keyboard next line. Tell them what we want, get their input, turn it into a double, save it as price. Why does it not like that? Oh, I didn't even have one, my goodness. So scanner keyboard equals a new scanner, given system.in, great. And then, yeah, let's add that import for scanner. Thank you, NetBeans. Okay. So now I'll ask them for the price, and now what we're going to do is we're going to calculate sales tax. So we'll say a double for sales tax is equal to the price times 0.06. Right, and then we'll have a double for total price is price plus sales tax. Right, just add the two together. So this is Michigan sales tax. Now, anytime you've got a number here, it's actually considered bad form. This is what we might call a magic number, meaning it means something in the code, but we don't know what because it doesn't have a name. So a better practice is to declare a variable like final double Michigan sales tax rate is 0.06. 0.06. Then I can use that variable here instead of 0.06. And now you know, oh, hey, that's the sales tax rate. I mean, you could probably guess it based on the variable name here, but now we've got a nice name for what that 0.06 is, and we're not going to change it by mistake. This is just a good practice. So best practice to use names for variable or constants, right? So if I know what it is, let's give it a name here. Let's do it the right way here. And then we'll have the total price. And then if I were to just output the total price, even add our $, it'll add total price. It's going to look super ugly, right? Which is not what we want. So let's go by, say, how about a Snickers? So a Snickers, I think, is what, $1.59 at the gas station? Okay, that's not the worst. $1.68.54. And I'm not going to pay them that amount, right? Probably we're going to round. And I don't know if they round up or down. I'm not entirely sure how that all works with taxes. It's a good question. But if we wanted to, we could just punt on that and figure it out later. We could do our own formatting here. So if we want a formatter, we can say, hey, I want a number format. We'll call it currency. And then we're going to say that equals, number format, and currency formatter equals my number format dot get currency instance. Now there's all sorts of cool different things you can get here. You get numbers, you get percentages, you can get currency. So we're going to look at currency here. Yeah, capital D double is the class double built in into the Java library. So you can do cool things like parse double. And you have all sorts of methods around double. Double with the lowercase d is the primitive type. That's all. Okay, so you can use currency formatter. And then what I can do is I can, instead of saying total price, I can say currency formatter dot format. And I'm going to format the total price. So a little bit longer here, right? But then we're going to use that currency formatter to format it for currency. And now what's pretty cool here is we actually get $signs automatically. And it rounds. Check this out. Enter the price item, so $1.59 for my Snickers bar, $1.69 rounded up with the correct $sign currency formatting. How amazing is that? So you can do that for percents, you can do it for numbers, you can say how many digits you want to round it to by setting the fractional digits, all sorts of fun things there. Lots of fun ways to do it. So if you like, rather than being this, making the currency formatter and saving it, you can just put this here instead. And I'll just copy paste it. We'll do it both ways here. Whichever you prefer. So one gets a little bit long, but it's not terrible. So instead of currency formatter that we're saving, we can just say, hey, number format dot get currency instance dot format something. Long, ugly thing here, but number format is the class getCurrencyInstance is a method that gives you back something, another class, and then format is another method. Don't worry about it. All that stuff will make sense later. We'll talk about all those names, but you can just kind of follow, do this, do this, do this, of that. And it's the same thing. Lots of different things. So essentially you can copy paste, follow that example. It's not too bad here. Yep. So we got rounding, debugging, yep. The big decimal, I'm not too concerned about big decimal. The quiz might ask some questions about it here, but we're not going to use it for anything. It's good if we're actually doing, want precise mathematics to use big decimal, because we're not going to get those weird errors. But again, pretty much everything we're going to do is going to round fine, because like when you get to the millionth, we don't really care because we're going to be rounding to the nearest penny anyway. So errors in the millionths for our purposes are probably not a big deal at our register, if we're doing one transaction at a time. But if you're a bank doing millions of transactions a day, those millionths can really add up if they go the wrong way. So it's worth doing depending on what you're trying to accomplish here. Okay, we'll see. We should get the same result out here both times. If you get the king size Snickers, I think it's $1.99, right? So let's do $1.99. So $2.11 after tax. Bummer. I do like Snickers though. I think that's my favorite candy bar. That and Reese's, definitely my favorite candy bars. If you couldn't tell, I'm a little hungry today. Although I'm trying to stay away from all the sugary snacks. It's not good for me. As I check my blood sugar here on my artificial pancreas. It's not too bad, see? Not too bad. It's fun to be a cyborg. All right. So I think that's pretty good here for the chapter. Let's talk about what we want to do for the lab exercise. So I want to talk you through a little bit of it here. Again, do this idea of this pseudo code here. Okay, so this is just more practice. So we're going to use some of these things here. The fast, I was never really into the fast breaks. They're good, but I would never be like, hey, I want this one instead of a regular Reese's, or I want that one instead of a Snickers. Anytime I stopped at a gas station. So we're going to write a number guessing game. So this sort of thing, I used to keep my kids busy for quite a while. They're a little older now. My youngest is 7, but the next oldest, she just turned 10, and she doesn't really think this is fun anymore, which is kind of a bummer. But the number guessing game, so we need to ask the user how high of a number they want to guess. And then we'll generate a random number from 1 to that number. Right, and if we're using this random here, right, multiply by the largest number you want and then add 1, we'll get you 1 to that. Okay? Then keep track of how many guesses it takes to guess the right answer. So we need a place to count the number of guesses, right? Ask them to guess a number between 1 and that number. And then if they guessed it right, tell them they got it right in X guesses. Otherwise, right, tell them if it was too high or too low and let them guess again. Here, so this is a loop, right? We're going to keep on going, right, until they got it right. So the loop is happening over and over and over and over if it's not right. Right, is what that means, right? So the loop happens, loop runs as long as it is not a correct guess, right? Because we want to let them guess again. If it is a correct guess, we don't need to ask them to guess again. Does that part make sense? Then we want that entire thing to ask if they want to play again. Loop the whole thing over again. So really that loop should start here then, right up here. Oops, oh my goodness. Getting the wrong characters here. Oh my goodness, why is it not? There we go. Again, loop starts. So start with that play again loop, or if you want to ask them if they even want to play here, sure, ask they want to play the game, and then, the play loop starts here, ask they want to play again, just like we did with the last lab, right? But inside we're doing it slightly different here. We're doing our guessing a number too high, too low. You can see these are if statements, if else statements here to do those checking. inside of that while loop, right? So while they want to play, yes, good, let's go. Then how high of a number, and then while they have not guessed it right, let's keep going. Too high, too low, guess again. Too high, too low, guess again. Right, and they keep on guessing as long as they want. Does that part make sense for lab? And let me go commit this to GitHub here. So this is chapter 3. Commit and push. Make sure this is all saved. I think it's all saved in there. Let's go view it on GitHub. Here's my window. There it is. So in chapter 3, let's go see if we have that pseudocode here. Perfect. I'm going to link out all this here for your assignment. Let's go. And we need our classroom GitHub. So again, clone your repository. Right? Start new projects in fresh source here. So here is going to be, now this is our lab 3 here. So okay, so this is lab 3. So we do next week before class starts. So that's 6 p.m. Don't forget we also have the first project coming up due as well next week. So we'll talk a little bit about the project if you folks have questions about that as well. Definitely want to take those. So this is the labs category. This is a text submission. Here's a link, invite link, copy. Submit the URL to the feedback pull request. And then we're going to see, or write the guessing game, a number guessing game. That copy paste never wants to work for me. I don't know why. See here. Okay, so we should have that one available here for the lab due next week. First project due same time. So again, ideally you're getting the lab out of the way. This one shouldn't take the rest of the night. We should have a little extra time as well. If you got a question about the project, happy to meet with you folks individually, hop on some screen sharing sessions, whatever, about the project. For this one, right, this was our knish recipe helper to make sure we get enough ingredients to make those delicious knishes. Delicious knishes. Man, I'm getting hungry again. So ask them for their name, use it in all the prompts. Ask them what type. Is it potato, beef, or chicken? Right. So when we get a string input, we need to say, hey, does it equals ignoring case? Is it potato, beef, or chicken? If it's not any of those, right, that kind of else case, like we did rock, paper, scissors. If it was paper, great. If it was scissors, great. If it was rock, great. Else, I don't know what you told me. Give up. Go away. Right? And then figure out how many people are coming to the party and figure out the right number of ingredients. This rounded up was math.ceal, right, for rounding. So math.ceal, some number for rounding up. Right? See chapter 3. Math.ceal will round things up. Calculate all the ingredients they need to buy, print out the number of ingredients they need to buy. Right? Calculate it and round it all. So we do that arithmetic. So remember, integer division will cause trouble for us because we're going to lose any decimal remainders. So we don't want integer division when we're calculating those. You want the double value and then you want to round it up. Right? Because if I try and round up here, if I said, hey, where was all of this stuff happening here? 10 divided by 3 here. So if I were to do this again, right, so this 10 divided by 3, so math.ceal, right, math.ceal of 10 divided by 3 is equal to math.ceal to round up, like ceal, short for ceiling, right, 10 divided by 3 here. What do you think we're going to get? Right, if we do math.ceal, round up 10 divided by 3. We still get 3 because we did integer division. Right? An integer divided by an integer gives me an integer result. When you round an integer to the next whole number, it's already at a whole number. It doesn't need to go anywhere. So we'll make sure one of these things is a double. So like 10.0 here, 10.0. Now we'll get that double result, and then we can round up. Right, and with the double result, then we'll round to the next nearest whole number. So that will round up properly. So you can beware of integer division when you're trying to do your arithmetic. It will cause all sorts of trouble for you, okay? So keep that one in your back pocket. Let me add this one here. This was our rounding. Rounding up with math.ceil. Okay, I'll commit and push that. And we should be in pretty good shape. Uh-oh, did that change my link? It might have changed my link for the lab. Uh-oh. No, it didn't. Okay, so if there's this big, long, ugly numbers and letters mix here, this is called a GUID, you're in good shape. And we should be fine. So if I refresh, it should stay just the way it was. Yep. So if I go click back to the file, though, back to week 2 and week 2 again, it's different line numbers because we have that rounding now. Where'd my rounding go? Oh, this was week 2. Never mind. That's not what I wanted. Was this week 3? No, I wrong one. Sorry. This is the wrong link. That was rock, paper, scissors, friends. We wanted chapter 3. Where'd it go? Did I not push? 1500 winter 2022 Tuesday. 1500 winter 2022 Tuesday. Oh, here's our number guessing game. Here's the chapter 3 link. What happened here, friends? Where's my chapter 3 link? Oh, I'm still not on. Okay, sorry. I need to go back to the home link. There we go. My goodness, friends. So let's change that one out. We'll delete all of this nonsense and give you the right link here. I'm sorry about that. Oh, but I want this permalink. There we go. If I copy the permalink, then it'll stay. There we go. Too many cool options here. All right, now that link ought to take you to the right location here. Sorry about that. Close out these other ones we don't want. Here, make sure that takes us to the right spot. Yeah, there we go. Okay, cool. And now do we see the math.ceil? We don't see the math.ceil stuff. So if I go back to the home here, and then go back into chapter 3, into source, chapter 3.java, I should see the math.ceil. Yep, here we go, math.ceil. So now it's there. Cool, life is good. Any questions, comments, concerns? How you folks feeling? It's meant to be a little bit of a stretch. I know, Trey, you said it doesn't sound easy. That's okay. That's okay if it's not. It's meant to, get us into some practice of doing our things here. Definitely. Okay, so we got the rest of the night. I'll end the stream here. Happy to hop on Zoom or Discord screen shares with you folks. Just shoot me a message. Let me know you want to talk. We got the rest of the night for that. And then coming up next week, we've got Project 1 due. We got the lab due. The quiz from Chapter 2 due tonight. I'll open up the Chapter 3 quiz here in a second. That'll be due next week as well. Like every week when we cover a chapter, we'll do the quiz. So this is your incentive to go read the book. Right? It should be free points because they're open book, open notes, open internet sort of thing. So all you got to do is go find the answer in the textbook when you see a question about it. Ideally, you know where to go look because you've read it. But again, we'll go from there. So that one's there, and then I'll turn on the answers will show up as well. All these dates are wrong. It's fine. I'll change the dates. Today on the 1st, so the answers will show up after the due date, or on the due date. So you can go see what went wrong. And again, if you got scored funny on any of them, please let me know. Happy to go correct those for you. I just would rather not go look at all 25 of these every single time. So if you notice it marked you wrong, let me know and I'll go fix it. If that sounds fair, we can go that way. All right, so we got the Chapter 3 quiz coming up. We got the lab coming up. We got the project coming up. Again, every week we're going to have something to get you into some practice, get you into reading the book. And we'll go from there, okay? All right, study group session tomorrow, 12 to 1. Happy to see people making that. It definitely makes a difference, spending more time on the topic. Right, getting a chance to practice it even more was going to make a difference for you. And Tim is phenomenal. He's taught the course before, so he worked in IT. He's got his little bio there in that SI document if you want to go read that. Did a lot of work in IT before he retired out of the industry, but he got a math master's because he thought he wanted to go teach math classes. So he mostly teaches math classes now, but he's taught this one before, so he'll do the tutoring for us because he's phenomenal. Okay. Any other thoughts, questions, concerns? Folks feeling all right? right, we'll call it good on the stream then. Let me put on the ending thing here. And yeah, we'll just stop it here. We'll go from there, okay? I'll talk to you folks in a little while.